Hey guys, thanks to the excellent beginner tutorials by Blender Guru, our social media is often filled with the same donut over and over and over and over and over and over and over. Some might consider it a crime against humanity, so I thought, well, in that case, I better make a donut tutorial then. Hopefully one with more interesting results. And although we're only making a donut, we're going to cover a massive amount of skills that are going to come in useful for any future project when trying to create professional quality work. And I'm really hoping that you'll use those skills to create your own peculiar, odd and interesting donut and then unleash it on society via social media using the hashtag #PeculiarDoughnut just so that we can all find it. And if you want much faster cycles render times and to save a ton of electricity, check out Turbo Tools version 3 at 3d-illusions.co.uk, where you can also find the completed scene files for this tutorial plus some variations in the members area. So add any object, doesn't matter what it is, I'm using a Suzanne, just make sure you add a geometry nodes modifier to it. And we'll start off by getting rid of Suzanne and we'll replace her with a cube. We use a cube because when we subdivide it, it'll create a much more even distribution of faces than if we were to use a UV sphere. So we'll go to Mesh Primitives, and we'll choose a cube and drop it onto the wire. We're going to subdivide it to make it a sphere, so Shift A, S, Subdivision Surface, and we'll give it 5 subdivisions. If you want to see the amount of geometry you've got, just click on wireframe and you can see it in there. If you pull down with Z and turn off toggle X-ray, you can only see the front side. And you can see we've got quite nice even polygon distribution. Just for comparison's sake, if we look at the UV sphere, you can see at the top we've got all these triangles that meet at a single point. And that's going to cause ugly deformation when we displace and subdivide. Whereas this one, because they're also evenly spaced out, we're going to get a really nice result. So let's get rid of this one. The next thing we need to do is add a texture. So Shift A, S, a noise texture. And I'm also going to use Shift A, S, a Musgrave texture. We change both of these to be 4-dimensional. And basically 4-dimensional means we've got an extra socket here to control the evolution of the noise. So we can change this over time by using a time node. So Shift A, S, time, and then we can connect the frame into the W socket. We'll change this to 4D as well. We'll connect that up shortly. So just put this out of the way for now. What I want to do is displace this based on this texture. Now, if you're using the latest version of Blender, I'm using 3.4 alpha. I got this today, 9th of the 10th, 2022. So if you get this one, or one from earlier this week, we've got a new feature which allows us to see in the viewport, if I just go over to solid view mode, if I Control Shift click on this, we get a viewer node, and if I then Control Shift click on this one, we can actually see the texture through the viewer node. So that's really cool. You couldn't do this before. You'd have to mess around creating shaders just for visualization purposes. Now, obviously, this is going way too fast. So Shift A, S, and then choose a math node, drop that in there, and then we'll choose to multiply this, and we can slow it down by multiplying it by a small number. So 0.01, you see we're getting quite a slow movement. And for quick access, I want to make some of these values available in the modifier. I can just grab this group input and I'll connect the values I want access to. So I'm going to plug this one in here and then I'll rename it speed. And you can see now it appears over here in the modifier. And if we want to change it, we can just drag it around and we'll get a different result. Right, so we've got that. How can we displace the mesh where the white areas are? What we need to do is get the normal node, set position node, we'll plug this in here, and we want to offset along the normal just the points that are in the white area of that noise texture. In order to do that, we've got the normal, and we need to use a vector math. We're going to multiply the normal by the output of the noise texture so that the white areas will push the points outwards along the normal. Just need to make sure we set this to multiply. And if we want to change the strength of the displacement, all we can do is add a math node, and basically we want to reduce the brightest areas of the noise texture, and the darker those bright areas get, the less the displacement will be. So just change that to multiply, and then we can use the value to change the strength. So let's make this one available to the modify front end as well. We'll call this one displace distance. We'll drag this across. Now, to make this even more interesting, I'm actually going to plug this one in to the W so that the first texture is controlling the evolution of the second texture. And that will cause the noise texture to pulsate between 0 and 1 as it receives black and white data from the first Musgrave. And then you can play around with the various values on the noise texture until you get something that looks pretty cool. I'm probably going to give it another subdivision, looking a little bit low res. There we go. And if we unhook this viewer now, by Control right click drag, or Control shift click in a blank area, we can see the result on the mesh. So I'd also like to control the scale of the first noise and the second one from the modifier. So I'll quickly connect those values to the group input and give them a suitable name. Musgrave scale and noise scale. To improve performance and make the surface a little bit smoother, we can turn the detail of the noise texture down to 0. And then we can add a little bit of distortion perhaps. And it's looking a little bit jaggedy. So I'm actually going to add Shift A, S, and this one's going to be a set smooth. Plug this one in here, and make sure we connect this one now to the viewer. So Control Shift click on here, and we need to put this one into there. There we go. The difference is if I turn the smooth shade off, you can see it's all faceted, where shade smooth on, it's a nice smooth result. And if you can get away with it, you can try increasing this to 7. Computer says no, so let's turn this back down to 5, and then put another one of these afterwards. Shift D, bring that across. Oh no, I've got to go down 5. I meant to turn it down to 1. That's a bad move. Control Z and hope for the best. Hey, it worked. Control Z worked. I wasn't expecting that. So Shift D, I'll duplicate A this time and not forget to change this to 1 for the subdivisions. So I'll try decreasing the first one to 4 and then I'll increase the second one to 2. And then I just want to modify the distance, which we can do over in the modify panel. Like so. And to keep things fast, I'm going to mute the second subdivision modifier and just turn up the first one a bit more so we've got more subdivisions before the displacement, so we get more detail. And what would also be really helpful would be to be able to have different subdivisions for the viewport and the render. And we can actually do that by adding a isViewport node, which will return a 1 if the render is currently happening in the viewport, or a 0 if it's happening in the final render. And then we can use that value to control which branch a switch node will output. So we'll firstly add the switch node with Shift A, S, and then switch. Make sure it's on geometry, drop that in there, and then we'll plug the viewport into the switch input. So I'll make sure the current setup goes into the bottom socket for the viewport, and then we'll duplicate that subdivision surface node and plug that into the top socket so that gets used during a render. So when it renders now, it's going to get 8 subdivisions, and just to get an idea of what that looks like, you can see that's a really nice result. So for the viewport, I'm going to put it back down to 6. And don't forget, like I did here, you need to connect the cube to the mesh input socket of the new subdivision node. I didn't realise till later in the video. Next up, we'll give it a bit of a material. So over to the shader editor, I'm going to add a new one. And in the shader, I want to turn on, at the bottom, subsurface translucency. And we'll give it a skin color, back into geometry node, and we need to, let's just move these out of the way, consolidate this, Shift right click and drag, Shift A, S, set material, drop that in, and then we can choose the material, which is material, we'll just rename this in fact, skin, and then we'll choose skin from here. And if we go into material preview mode, we can see that in there. So let's go back into the shader. Let's turn on subsurface scattering. We'll give it a little bit of shine, not too much. Let's go into the render settings under EV, and just to make it look a little bit nicer, we'll turn on screen space reflections. Make sure the render engine is set to Eevee at the top of the render properties. And then we'll change the viewport to Eevee mode. And we'll untick Use Scene World just so it's using the default. And just to get that subsurface looking a little bit nicer, we'll give the subsurface a red colour, probably a little bit too glossy. Turn that up a little bit. And we can see now that the model looks quite jagged from the side. So we'll go back into geometry nodes, and on the pre-displacement subdivision surface node, we'll reduce the level to 5, and then we'll unmute the one after the set shade smooth, and that will make sure that the jagginess that has been caused by the displacement is smoothed back out. And one final obvious thing is you probably want the modifier to affect the actual object that the modifier is on. So let's add an option to do that. All we're going to do is swap between the cube and the input geometry. So Shift A, S, group input. We've got the geometry socket here, so we'll just copy this switch across, Shift D, plug it in there, and make sure this connects to both. And on this one, we'll plug the geometry into the bottom. And we'll plug this one, the empty socket on the group input, into the switches true or false. And we'll just name that Use Input Geometry. So when I change this to 1 over here, it will use the actual monkey instead of this cube. Now we've got to be very careful. Obviously, I'm using 5 levels of subdivision here, and I'm also using another one down here. Now, because Suzanne's got more faces than the cube that we start with over here, this could cause quite a few problems regarding, well, maybe a computer even crashing, particularly if you're not using a Suzanne, but a more dense model already. So to avoid that, when we first apply this to a new model, if this Use Input Geometry is set to 1, which I think I'd like the default to be, then we need to make sure that these are turned right down. And in order to do that, we need to give the user the options to change them in here, but also set a default value. So let's do that now. Firstly, we'll give the user the access to them, so we'll plug them into the input. So the first one is going to be the render time. So let's just change this, render pre-sub, and this one, viewport pre-subdiv. So we've got these over here now. And we can see that it inherits the default value from whatever was set when we first added this into the input. So let's change that to default of 0 and viewport default of 0 as well. That just makes sure that if the mesh is already heavy, we're not going to risk crashing the computer. And we'll also change it so that when you first add the modifier, the user's geometry is used by default. So let's click on this one in the group inputs over here. This is in the group tab, by the way. And we'll just tick this default. So that means by default, it's going to be turned on. And if we want to, we can add a tooltip, user's sphere when not ticked. We'd also probably want to give the user access to different settings at render time for the subdivision surface after the displacement. Very quickly, we can do this. Shift D. We'll bring this over here. So viewport's going to be the bottom one. We'll copy this one. Plug this into the top. We'll duplicate this, Shift D. We'll plug this one in there. And we'll plug this one into false, which means when it says, is it the viewport? It says yes, it's going to use the bottom one. No, it's the render, so it's going to use the top one. And we want to give the user access to these as well. So again, Shift A, S, group input, and we'll plug this one at render time. And we can just duplicate this below so we don't have crossing wires. We'll name these. Render post subdiv, viewport post subdiv, and the defaults of these are fine, 1 and 1. And then we can change the order of the options on the modifier's UI by just selecting them in the group panel and then using the arrows to move them into whatever position makes the most sense. At the top over here. We could also obviously add, probably a good idea, the material that's going to be used. So we'll plug this one in there. That's going to default to skin, which is probably not ideal. So we'll select it in the group panel and just remove the default value. Let's just quickly test out the modifier now we've finished making it on a new object just to make sure all the defaults work correctly. So Shift A, and we'll go with a donut. Add the modifier. Give it a material. We can see all the defaults have worked correctly, so that's good. We need to turn those up then. So we'll go with 2. And we can't see much of the subsurface scattering at the moment because we're getting too much light coming from the environment. So let's just make sure we turn the scene world on. And we'll also make it completely black. So let's go across to the shader editor, into world mode, and we'll just set the background color to be completely black. And now we're getting no light whatsoever. So we're going to need to add a light. We'll go with the sunlight. And straight away you can see we're getting nice subsurface scattering underneath the object. Now let's rotate this sun around a little bit, just make it a bit more interesting. Probably about there. We'll turn off the overlays. If we play this back, you can see we're able to start tweaking this now, just by changing the options we've given ourselves over here. Now I want to make this look a lot more grotesque. So what I want to do is give it a mucusy green colour where it stretches out, but I also want the skin to look as though it's becoming more shiny and thin as it stretches as well. And of course we'll give it a bit of a rough texture. The first thing we'll do is use a mix node to specify the 2 different colours, one for the skin and one for the stretched out green part. We'll copy this one for the skin, Ctrl C, Ctrl V, and for the bits that pop out, I'd like them to be sort of a slimy, phlegmy, mucusy green sort of colour. And we'll plug this in. Now the problem is, of course, at the moment we've got nothing telling it which of these colours to use for which parts of the model. So we need to somehow do that. We don't want to just use this slider. And while we're at it, I'm going to plug this also into the subsurface colour. So at the moment we can either have red if we slide the factor to the left. In other words, that would be black if there was an input coming in, or white if we slide it to the right, and then it's going to turn green, so it's the bottom slot. White gets the bottom slot, black gets the top slot, black is equal to 0, white is equal to 1. So to get this information, we can actually use the geometry nodes that we made earlier, because if you remember, the texture nodes output a black and a white image which specifies that the white is the bits that are stretched and the black is the bits that aren't stretched. And to get that information into the material editor is actually very straightforward. We'll just put down a store named attribute node. We'll put that after the switch node so that we make sure we're getting the right geometry. Make sure it's on float because the noise texture outputs a float, and then connect that up. And then we'll name this to lumps. And all this data is going to be written into the point domain, which is fine, that's what we want. So with that done, we'll go back to the shader editor. I'm going to drop down a node called attribute, and we'll enter the name of the attribute that we want, which was lump. Now if we plug the factor into the factor of this, it should work straight away. And there we go. So we've got the green parts on the outside and the skin colour on the inside. And if we want to control this a little bit, Shift A, S, and we'll drop in a ramp in between. And then we can slide, the further we slide the black to the right, the further up the lumps the skin colour is going to come. And the further we drag the white to the left, the further down the lumps the phlegmy green is going to come. And so we can get a better idea of what it's going to look like when we actually composite in the end, let's just go into the render panel, down to the bottom, turn on use curves in the colour management section. We'll just drag this to the left a bit, maybe to about here, maybe increase the mid part as well. So that gives us a better idea of what it's actually going to look like when we finish compositing. So we definitely want to turn down the strength of this a little bit. Maybe we bring the value down and bring this down as well. Make it a bit more of a phlegmy yellow, perhaps. About there. Next up, we want to make the subsurface scattering get stronger as it stretches out, so the skin looks thinner. And we use the same attribute, so let's copy these across. Bring it down. And I'll just actually name these. So select those, Shift P, go into the end panel by pressing N, and we'll call this base and SSS. Do the same for this one, Shift P, and we're going to call this one more SSS where stretched. And get rid of the mix node on there. I want to plug the colour into the subsurface value. And it's still using the attribute that we brought in. And if we drag this to the left, so the left hand side, don't forget, where it's black, is the bottom of the lump, so just the normal skin, and then the white area is the bits that are sticking out. So let's drag this to the right a bit. And we can use this as sort of an ambient occlusion as well. We don't need to be completely no SSS in those areas, so let's bring this up a little bit, maybe to about a greyish colour, about there. And we can add a multiplier, Shift A S, add a math node, we'll drop this in here, and then we can use this, set it to multiply, to have more control over the result without having to move these individually. So I'll set it to 1. And the next thing, how the different colours travel through the object. So this is done with the subsurface radius. Now, by default, it's set to 1, 0.2 and 0.1. And these represent the distance the red, green and blue can travel inside the mesh. And this is perfect for skin, so I'm going to leave that as it is. Now, the thing you can do with Eevee that you can't do with cycles is we can actually control this subsurface radius using a value node. So Shift A, S, value. We'll put this here and plug that into the subsurface radius. And this will act as a multiplier for whatever values were in the subsurface radius before we connected the value node. Set it high, we've got sort of a jelly baby look. And we want it to be quite subtle, so probably around about there. And I'll call this one SSS multiplier. And next up, we want to make it glossier where it gets to the edge. So I'm going to copy these again. Shift D, bring those down. And this one is going to go into the roughness. Now the roughness works the opposite way around. The black colour is glossy and the white colour is rough. And because our lumps attribute is coming in as black to white, where black is not stretched and white is stretched, we need to change the colour ramp so that the left hand side, where it's black, not stretched, is white, so that makes it rough. And then the white side, where it is stretched, we change this to black, and that will make the stretched part shiny. And same as before, we can now use the ramp to drag the rough areas further up the lump, and now the glossy areas further down the lump from the top. And then just play around with those until you get a look that you like. Next up, we'll add some bumps to make it look more realistic. So Shift A, S, add a bump node, connect it to the normal socket, and then we'll add a Musgrave texture, Shift A, S, Musgrave, drop that in, and then plug this into the height. We need to give it some UV coordinates. So with the Node Wrangler add-on installed, Ctrl T will automatically add these two nodes for you. And you've got a couple of options here. You can use generated or UVs, and it will move in unison with the actual geometry. But in this case, I think that looks a little bit weird. Let me just turn the strength down a bit. So you can see it's actually moving, it's sticking to the geometry. But because these lumps appear to be sliding left and right, it doesn't really work in my opinion. It would be better if this actually distorted, these lumps distorted a little bit and sort of moved around to sort of fake moving left and right. So I'm going to use the normal. Let's plug that in, and it will do it based on the angle of the geometry. And you can see that now appears to be moving around a little bit. Let's just turn the strength up a tad. Maybe bring that scale down, maybe 3.3. Turn the detail up, and then we're going to bring the dimension down. Let me just stop playing. If we Control Shift click on this, we can see it on the model without being distracted by the material. Bring the dimension down now. It's about there. We just want a bit of a rough skin sort of a look. And now we can control the distance between the black and the white. Shift A, S, put down a ramp. And further drag the black to the right. If we Control Shift click on this one so we can see it, it'll increase the gap between the white areas so that we've got more of a gap between where the bumps stick up. I think we'll turn the dimension right down. Maybe about there. 1.85, let's try that. This should look quite good, I think. So let's go back to material, Control Shift click on it. Yeah, so we're just getting a nice subtle amount of bump showing through, and it's having a nice effect on there. And you can tweak it to your heart's content, but I'm going to leave it about there. But I'll include a few variations of materials in the files that are available in the membership area, so you can check those out if you want to try some different skin types. If you play that back, that is starting to look pretty disgusting. Let's just name these. So Shift P in the end panel, and I'll call this one Bump. And I'll make sure I name all these as well in the downloadable version. And of course, no self-respecting donut wants to be seen out in public without some form of topping. And in keeping with the theme, rather than using sugary sprinkles, we'll go with something a little bit more grotesque. So over to the particle system, we're going to add a new particle system, and then we'll choose hair. Let's zoom out a little bit. The settings, I think we'll change this to a 500, so a few less. The length, I want it to be much less, so maybe 0.2. And I want to make sure that it's using the modifier stack, so that it's getting its placement from the geometry after it's been modified by the geometry node system. So click on that, use modifier, and now the hair should all be pointing away based on the normal of the face that they're sat on. Next up, I want to make sure the hairs only sprout out of the top of the donut, not at the bottom. So I'm going to go into the data panel and add a new vertex group. So click plus, and we'll call this hair location. If your machine is going a little bit slow at this point, we can go into the modifier and just turn the viewport subdivisions down a little bit, to maybe 2. Turn on overlays, and then we'll go into the weight paint mode. Turn the weight to 1 so that we're painting full strength. Make sure strength's turned to 1 as well. And now paint on top of the donut where you want the hairs to sprout out from. And if you overpaint any areas, you can change the weight to 0 and then just unpaint those areas. Back into object mode, and then we'll go back to the particle system, down to the bottom, and we've got a section called Vertex Groups. So this is where we can use vertex groups to control different aspects of the hair system. So I want to control the density with the vertex group hair location that we've just created. And straight away, we can see that the hair now only sprouts out of the top. Now it's looking a little bit thick to be hair, so under the hair shape section, we'll reduce the diameter of the root to something much smaller, so maybe 0.2 meters, which still seems incredibly wide for a strand of hair, but it seems to work, not sure why. But of course for your model, it could be completely different, just depends how big your model is. We need to give the hair a material, so we go into the material panel, over to the top, and we'll add a new one, and then click new. Over to the shader editor. We're going to stick with the principal BSDF because the hair BSDF doesn't work inside of Eevee. I'll probably go with a reddish colour for the base. So we can't actually see the material in the viewport yet. We need to go back across to the particle settings under the render section and then replace the skin material with the new one. Probably a good idea to rename the material as well. We'll make the subsurface scattering colour an orangish colour as well. And just for a little bit of control, we'll add a value node, and we're going to plug this into the subsurface radius. And we'll set the value to 1. Then just darken the colours until the effect is how you want it to look. Somewhere about there, we can tweak it later. And make sure you keep the roughness turned on and the specular turned on as well. You can turn this down to get a more shiny hair, but we'll come to that later when it's easier to see what the material's doing when we've added more hair to it. So let's go down to the children section, and we're going to turn on interpolated. For now, just so we can see what's happening, we'll put it to 1. And I think considering the context, it's only right and proper that these hairs be of the curly variety. So let's go into the kink section, select curl, and it's a bit too low resolution to see at the moment. You can see all these hairs are very jagged, so we'll go up to the viewport display and just increase the strand steps to 6, and now we can see the curl. And we'll do the same in the render as well, so we don't forget. Now the amplitude of the curl is a little bit too much, and also there aren't many curls in there. So back down to the kink settings, and we'll turn the amplitude down to something much lower, maybe 0.07, so they're not as wide. And we need more frequency of curl, so let's change this to a bit something higher, maybe 8. And there we go. That's looking not very good yet, but if we turn up the number of children, let's go with maybe 15. We've got much more coverage. And we'll just turn the overlays off so we can actually see a little bit better. Now at the moment it's very uniform and the curls are still probably a little bit too big. And in order to counter that, we're going to just make a few little tweaks, and to do so we need to turn on the advanced option so that we can access the physics tab. And if we go down, we've got a physics area where we can change the Brownian, which will just make these rotate a little bit in different directions. So let's go with something really small because we don't want them to sort of cross back into the mesh. 0.05 should be the ticket. You can see that's messed the hair up a little bit. And at the moment the hair doesn't look very realistic. So what we need to do is add some shadows to it. We'll go into the sun and then we'll just turn on some contact shadows and then turn down the thickness until it looks good. We'll also add a tiny bit of roughness, which is going to be similar to the Brownian. So let's go back into particle settings. Basically this is going to move things around a little bit. Now we're going to need to be very careful because we don't want to slide things around on the mesh too much, otherwise the hairs will no longer be following the correct face location of the distorted mesh. So I'm just going to go with something extremely small, only on the random. I'm going to go with 0.2 and I'm going to turn the scale down to something like 0.68. And you can see this is giving us a really more natural look, but the hairs and the curls are all the same size and the same length, which for a donut is completely unrealistic. And I'd also like to make the density a little bit more sporadic as well. I don't want it to be, you know, a very full, healthy bush. I want it to be quite disgusting, sort of a straggly look. So we'll go down to the bottom, and we've got something in here called textures, and we can actually use a texture to control different aspects of the hair. So let's create a new texture by clicking on New. We'll call it Hair Control. And then we'll click this button on the right hand side. This will take us to the Textures panel where we can choose what sort of texture we want. We could use a movie or an image if we wanted to, but I'm going to go with clouds. And I can choose which aspects of the hair this texture is going to influence. And that's under the Influence section. And of course we don't want this texture to influence time, so untick that one. But we do want it to influence the hair length, so check that. And now you can see we've got varying lengths, which is looking more straggly and grotesque. And then to make it look even more natural, we'll randomize the kink amplitude and the kink frequency as well. And then under the mapping section, make sure you change this to UVs, just so the texture will move around correctly with the model as it deforms. Now because the noise texture controls the attributes of the hair by using black and white values, we can have more control if we go into the colour section and start actually tweaking the colours a little bit, or tweaking the brightness and the contrast between the black and the white areas. So the black areas of the texture are going to be where there is no length, and the white areas are going to be where there's full length. So as you can see there, if we change the black to white, then everything becomes full length. So let's make it sort of a medium grey, and then we won't have any areas that are completely bald, but we'll still have variation in length. So I think maybe about there. And so we get less of a gradual build between short and long hair. We'll increase the contrast to 5, and that's given us a much more obvious transition between bald and full hair. And you can see this in the texture. We've got dark areas and white areas are no longer gradually transitioning into each other. And of course you can change the size and the depth and things, or you can even change the type of noise, but I'm pretty happy with this, so I'm going to stick with that. And if we play this back now, we can see that that hair is going to move perfectly in unison with the deforming mesh underneath. And now for the really important part, the most important part in fact probably of most 3D workflows, is the compositing to make the image pop and look realistic. But before we can do that, we need to add a camera. So Shift A, I'll choose camera, and then we'll do Ctrl-Alt-0, and that will align the camera to the current view. We'll go to the camera options and turn down the focal length until we can actually see the item in the view, and then go into the end panel and just make sure under the view options you've got camera to view enabled, and this will mean that you can rotate the camera around as if you were rotating the viewport. So find an angle that you like, and if you want to, add another light. I'm going to just illuminate this side a little bit more, and so that I don't need to move this viewport around while I'm positioning the light, I'm going to open another 3D view in the bottom, make sure turn on overlays, and then in this one, Shift A, light, and I'm going to go with an area light this time. I'm going to choose to align the area light to the view. Okay, and if we go over here, we can then manipulate the light in the bottom viewport until it looks good in the top viewport. Right, and now on for the compositing, where we can make a crap image look good. Or as they say, we'll polish the turd. And before we do that, we just need to make sure that we've got the modifier set up correctly for render as well as viewport. So let's go into the modifier, and we can see here geometry nodes, it's not turned on for render, so I'm going to turn that on. Yours probably is. Render pre-subdivisions, I need to give these some value. I'm going to go with 4. The lower you set this, by the way, the faster it's going to render. And then just for the particles, I want to make sure I've got the same number of children for render and for viewport. And I also want to increase the number of steps. So the steps for render, I'm going to set 7. I'm also going to do that for the viewport as well. And then you can see for the render amount in the children, I've actually got 100 hairs, which is not what I want. I want to set this to 15 so that it matches what I can see in the viewport. And then we'll head across to the compositor. Make sure you've got an image editor visible and that it's set to the render result. If you're not sure how to modify a workspace, by the way, all you do is you drag from any corner of an existing panel and then you choose what you want that panel to show. So make sure it's image editor and set it to the render result. And then check the number of samples, 64 and 64. So 64 for the render should be fine, I think. Probably overkill, but we'll give it a go. So F12, and there we go. So we've got the result in the render image editor. And the reason we've got the image editor open is because we're going to do something incredibly important now, which is to use the scopes to get the absolute best image we can get without having to try and see all the different values in the actual picture itself. So press N while your mouse is hovered over the image editor and go to the scope section, and the second one down under waveform, change this to parade. And this is going to show you the red, the green and the blue channels are indicated on a level meter of 0 to 100. And you may need to make sure that it never goes above 100. Otherwise, you're going to be clipping white data, which means you're going to be losing all the information in the very bright parts of your render. If you've got really bright reflections that you can still see other things in, and you go above the 100, all the things that you can see in those reflections are probably going to disappear, and it's going to look awful. The same goes for the 0. You need to make sure that none of the pixels ever go below 0, but it's also a good idea to make sure that the lowest pixel you've got touches on the 0 line, so that anything that's supposed to be black is black. Otherwise, your image could look washed out. We're going to turn on the backdrop, so click on the backdrop at the top, and then we Control-Shift-Click on the render layers, and this will bring up a viewer node for us if you've got the Node Wrangler add-on installed. Shift right click and drag to consolidate these into one line, and we can start manipulating this image now so that we can get the image as bright as possible without losing any data. So we do Shift A, S, RGB, add an RGB Curves node, and we'll set 1 for the black levels. So I'm going to open the end panel, go into the node and just call this black levels. Shift D and I'll copy this. I'm going to call this one white levels. Now regarding black levels, this image is actually fine. You can see that none of the pixels go below 0 and there's not a gap between the 0 and the lowest pixel. So it's fine, but I'm going to show you anyway how you would fix a problem if you did have one. So let's move this left hand side bit upwards a tiny bit. So you can see on the image looks really sort of washed out and it's lacking any contrast. And this is because the lowest black level is just above 20. So we need to move it down until it's on 0. So what I would do, let's just for demonstration's sake, I'm going to duplicate this, put it here, and we're going to pretend that this is what the image looks like instead of coming out of there. We'll put this back down. What we'll do on this one is drag this bottom one to the right a little bit, and this will bring the black levels down. Now it's very difficult to control because it's such a small area to move. So what you would do is you would move it a little bit until the blacks go below the 0 line, and then you can use the much less sensitive factor slider to get it just right so that the bottom pixel again is directly on the 0 line. And there you can see we're back having the correct result. So I'll just reset the tree. So now I want to get the white levels so that all the top areas go up to the 100 line. So I'm going to go into this one and drag this to the left. You can see the image is getting much brighter, and that's also being indicated over here. So that's the very dark and the very bright pixels sorted out, but what we've done is we've inadvertently raised the gamma, or the mid-range of the brightness, to be too bright. So I'll drop down another RGB curve, and then we can manipulate the gamma just by creating a new dot in the middle and dragging that down to balance the image back out. Now one thing I forgot, you must always, when compositing, go into your render settings, go down to the bottom, and just make sure that Filmic is changed to standard. The reason is, every time you do something in here, if you've got Filmic enabled, then whatever you do, Filmic's going to do something else to it to make it different to what you wanted. So it's very counterintuitive. So let's just do this again. Now you can see we've got a much better image because we're no longer fighting with the Filmic algorithm. So I quite like it about there. And something I'm not going to do here but I think would be useful to show is how you would add contrast as well. So we'll add another RGB curve. And basically you would put a control point at the left and a control point at the right, and then you can bring these closer together at different points in the image. So let's say for example I want more contrast in the dark area of the image. I'd bring this over here, and then I could bring this across, and I'm now adding contrast just to this dark portion of the image. So it gives it a bit more control than using, for example, the contrast node, because this doesn't give you the ability to control different areas of the image. And now we'll add the tried and trusted instant realism node, otherwise known as the lens distortion node. Now the lens distortion node has got something called dispersion, or otherwise known as chromatic aberration. And what this does is it offsets the red, green and blue pixels, and it sort of separates them to create the effect you get on a camera around the edges of the image. So let me show you what I mean. We'll put this up to 0.5 and we're going to get a really strong effect. Obviously that is not what you want, but just to demonstrate, this is what you get. You get sort of a rainbow effect around the edges where the pixels get moved apart. 0.05 is usually quite a realistic result. It's very subtle, but it definitely adds a bit of realism in there. We can also distort the image by pushing the middle part of the image away or towards the viewer. So negative will take it the middle away, negative 0.5 for example, and positive 0.5 will bring it into the middle. And if you get this weird loss of pixel data, just click on Fit, and that'll make sure your entire image is filled with pixel data. I'm using Alt, middle mouse and dragging around there to move that. I'll turn this off. I'm going to set the distort to maybe 0.1. And now for the new feature in Blender. Oh, and if you're using Turbo Tools, by the way, you're going to have this additional node here which replaces render layers. The feature I'm about to show you, you need to get rid of this. Don't worry, you can bring it back at any time. It's always saved on disk. So you go to Turbo Tools, select the render layers node, and just choose Cache Uncache. And that will get rid of the render layers cache node until next time we either render or press refresh all. That's necessary in order for this new feature to work. So into Edit, into Preferences, under Experimental, we've got a real-time compositor. If we now go back to the 3D viewport, and we can go to the option over here to turn on the compositor, and whatever we've done in the compositor now will show up in the 3D viewport. And that's really handy because you might want to make small tweaks. Now that you've composited and got all your levels right, you might still want to change a few things in the 3D viewport. I don't know, maybe the color of your hair, or you may want to have some more subsurface scattering, whatever you want to do. And you can also change the values of your compositor nodes and they'll update in real time in the viewport. For me, I'm quite happy with that in actual fact, so I'm just going to render it out. So we go to the output properties, then in here we can tell Blender where to save it and what format to use. So I'm going to save it to // which indicates to save it to the same folder that the blend file resides in. Then the name of the folder, if it doesn't exist, it will create it at render time. And then the name of the file. I call it Grotesque Doughnut. You've got options now to what file format you want to save it out in. Now you can choose to save it out as an image sequence, and this is a good idea because it means that if Blender crashes during rendering, then you're still going to have all your images that you've already rendered. You won't have to start from the beginning. You can just go up here and change the start frame to continue from wherever it crashed. And then afterwards you would recombine those either in Blender or in a different compositor. Although of course if you're using turbo tools you don't need to worry about that at all because that will take care of everything for you. For the sake of the tutorial I'm just going to go with MPEG. I'm going to change the encoding to be MPEG 4 just so I can use it in DaVinci Resolve when I make this tutorial. And I'm going to need to change the output quality to something a little bit higher, maybe perceptually lossless or high quality. I'm going to go with perceptually lossless. One thing you do need to do is go to render and choose lock interface. This will make sure that nothing is calculated in Blender while it's rendering. It will reduce memory and it will just speed things up a little bit. And I'm going to go back to compositor. I'll get rid of this by pressing N again so I can see what's happening, and then this will report to me as it renders what frame it's on. And just before you render, if you want to make your animation a bit more interesting, what you can do is add some audio. So go across to the workspace plus icon at the top right, and we'll add a video editing workspace. I always turn off the seconds because I find them confusing. Scroll all the way out so we can see the entire timeline. Shift left arrow will put the playhead to the first frame of the animation, and then you can just drag in your audio and then drag it into place so that it covers the full range of your animation, indicated by the lighter grey area. You can choose to see the waveform, so display waveform. If you zoom in, you can then modify that further by, for example, turning up the volume. Just make sure you don't get any of those red marks, that indicates you're turning the volume up too high. And providing you've not chosen to render an image sequence, you've chosen one of the video formats, FFmpeg for example, then the audio here will be included in the output file. If you are rendering to an image sequence, that's no problem. You can just bring the image sequence back into the video editor afterwards, render again, and then they'll be combined together. Or if you're using turbo tools, you don't even need to bring the image sequence in because it will use its own cache. All you do is go to the compositor directly after rendering and click publish, and then it will publish the animation, including the audio, to whatever format you want. So back to the compositor, we need to tell Blender to include that audio in the output file. So into the output properties, down to the audio section, and just give it an audio codec. AAC is a good one for MP4. And then you've got a few more options if you want to change these, the bitrate and things. I'm going to leave those as default. And the final step, press Ctrl F12 and the render should begin. And here's the end result. It's pretty gross, but I think there's a few improvements I'd like to make. So I'm just going to reduce the length of the hair, tighten the curl by reducing the curl amplitude, and maybe just rotate the light a bit, and then I'll render again. And here's the improved version. All I did was increase the hair count and the other changes that I mentioned before. And I think that looks much better because the light is getting through and we can see more of that subsurface scattering because there's not as much hair blocking the light. And I made a few variations on the materials that you can download from the members area at 3d-illusions.co.uk, but I'll show you briefly what I did. So you can see on this one, the texture on the skin isn't moving around in places where it's not been stretched outwards. And the way I did this was just to assign the static UVs to the parts of the model that aren't being stretched using the lumps attribute to mix between the normal UVs and the static UVs. And then I used the attribute again to control the strength of the bump so that it was stronger at the bottom of the lump and got less and less as it got to the end, just by using this inverted colour ramp. And then we've got this one that just looks a little bit more dirty and dingy. And basically all I've done here is increase the height strength to 0.695, and then again I've used the lump attribute to reduce the strength of the height as it becomes stretched. Similar to the last example, just with a slightly different method. Additionally, to make it look a bit more grungy, I've used a slightly different variation on the subsurface. What I've done is, I've lowered the subsurface strength, which is this one, the subsurface, and instead of using that for the subsurface, I've increased the SSS multiplier, so that's the radius, and that will give you a little bit of a different result. And as well as that, I've just reduced the subsurface scattering on the bits that aren't being stretched just by making this one a little bit darker and dragging it to the right. And that's the end of the video. So I hope it's been useful for you and you've learned some stuff. And I'd certainly love to see your own spin on a interesting and peculiar donut. And if you're going to share it on social media, use the hashtag #peculiardonut, and that'll just make it easier for everybody to find everybody else's work. So thanks for watching, and I'll catch you in the next one.